Welcome back, everyone. In this lecture, we're going to formally go through the solutions for the workbook for the MileStone Project 1, that tic-tac-toe game. Let's open up the notebook and get started. Alright, here we are at MileStone Project 1 Walkthrough Steps workbook. Let's start with step 1, which is to create a function that can print out the board. And there's lots of different ways you could have printed out the board. You could have gone with a really fancy board or a really simple one that just displays the list. But remember, we're expecting board to be a list. So the first couple things we're going to need is to actually print out the index positions of that list. So it'd be nice if we did something like board at 1 plus, and then some sort of indicator that we have a new column there. So we can do that. And then we'll do board at 2 plus, and then another pipe operator. And then finally board at 3. And then I'm going to just copy and paste this. And now let's change up the index positions. So 7, 8, and 9 on top. And it's up to you if you want to reverse that, but 4, 5, 6 will always be in the middle there. And let's check what this looks like if we display the board. So we run this, we display the board, and right now my test board is blank. So let me copy over the test board from the original workbook. And now when I run this, I get back my board. So this is a really simple version of the board, but it works fine. Now, something to note here is that if I run display board multiple times, so let me call it twice here, what's going to happen is I actually see a history of all the boards here. So in order to avoid that, what we could do is call clear output first. So if I call clear output, and as an alternative, if you're running this at the command line, you can use this print statement we talked about. If I now have clear output, what's going to happen is I only see one version of the board. So this would display the board, and the next time the board gets displayed, so next time you call display board, it's going to clear the output for you. So this is a really simple version of printing out the board, and we can keep it for now. But I'm going to copy over and paste the solution workbook, which is essentially the same idea. It just has a little sleeker bit of formatting here. So if I run this, I get back kind of a more spacious board to look at. It's up to you what you want to do here. Lots of different options. Main idea was to be able to index board and then print it out. Step 2 was to write a function that can take in a player input and assign their marker as X or O. Again, lots of different ways we could do this, but something we definitely wanted to do was to use a while loop. That way we can continually ask until you get a correct answer. So I'm going to set marker as an empty string, basically anything that's not X or O. And I could do this two ways. I could say while marker is not equal to X and marker is not equal to O. So I could do it this way and then say marker is equal to input player 1, choose X or O. And then what I can do is uppercase this in case they accidentally put in a lowercase x or a lowercase o. And finally, I'll return some sort of tuple assignment. So I'll say if marker is equal to X, return X, comma, O. And so the format here, I can write myself a little note. And in fact, this would be a good case for a docstring, is to say that the output is in the form of a tuple with the player 1 marker, comma, player 2 marker. So then when I check player input, the docstring is going to tell me what the actual output looks like. So you can check out the previous lecture for a more detailed version of this. This is kind of a cleaner version. Then we'll say else return O and X. And this allows us then to use tuple unpacking. So if I run this, then I can use tuple unpacking something like this to get back player 1 marker and player 2 marker. So I run the input, if I pass in X, hit enter, and I check out my player 2 marker, it's going to be the opposite of X, which is O. And if I check out my player 1 marker, it's going to be X. So different ways you could do this. The other thing I wanted to mention is instead of doing it with not equal to and not equal to, you could have said, while not marker equal to X, or marker equal to 0. So you could have said, while not this case or this case. So different ways to think about it logically. It's kind of up to you which you prefer. Moving on to step 3, we wanted to write a function that takes in the board list object, a marker, X or O, a desired position number, 1 through 9, and then assigns it to the board. So what we can do here is say place marker, board marker position, and I will say board at that position is equal to marker. So let's run a test to make sure this actually works. What we're going to do is say place marker. I have right now a test board. So if I take a look at what my test board looks like, it's the one from above, where I have a hashtag first to kind of block out the 0, and then X's and O's. I'm going to say, put in something new there. So let's make it really obvious with a $, and then put it at position 8. So I'm going to place the marker and then display the test board here. So let's run that, and we can see that it successfully put in the $, at the position we want. And that was just a simple, basically, at that board's position, place the marker there. Okay, step 4 was to write a function that takes in that board list and some marker, like X or O, and checks to see if that marker has won. So we have to ask ourselves, what does it mean to win tic-tac-toe? Well, it means that we need to check in the possible combinations. So we know that there's going to be 3 across. So we need to check all rows and check to see if they all share the same marker. So if they all share the same X's or they all share the same O's. So we need to do that for all the rows. Then we need to do that for all the columns. So that's going to be 3 columns there. Check to see if marker matches. And then finally, we have 2 diagonals to check. Diagonals. And check to see if we have matching there. Now we can use indexing to grab the example rows, the example columns, and the example diagonals. I'm going to show you different ways to do this, and then we'll copy and paste from the solutions because it's a lot of checks. So one way we can check for everything matching on all the rows is the way we showed you in the solutions notebook, which is to say board, let's do the bottom row. So we'll need to check board of 1 equal to the mark and board of 2. Let me make sure I check that right. Board of 2 equal to the mark and board at 3 equal to the mark. So what this does is it goes ahead and checks, hey, is the position at board 1 equal to the marker? Is position at board 2 equal to that marker? Remember that marker is the same that you passed. It's either going to be X or O. So if it passed an X, it's going to say at this position is it X, and at this position is it X, and at this position is it X. If we have this case true, then we know someone has won. It's whatever this mark is, has won. And in that case, we would just return back some sort of Boolean that they've won the game. And then what we could do is wrap this in a parentheses right here, and then have an OR statement, and then check for the next row. So we could say board at 4 is equal to mark, and so on, 5, 6. Then the next one would be 7, 8, 9. And then we could do the same for the columns, and the columns would be things like 7, 4, 1, 8, 5, 2, 9, 6, 3. And then we have the 2 diagonals, which is going to be those numbers, 7, 5, 3, and 9, 5, 1. Now this is how we did it in the notebook solution because it's a little more obvious what's happening here. But as an alternative, instead of using these AND operators along with checking mark for each individual index position, what you could also do is just check that board of 4 is equal to board of 5 is equal to board at 6, and then finally check that this is equal to the mark. The reason you cannot just do no check to the mark is because if the board starts off blank, then it's going to report back, hey, these 3 blank positions match and someone's already won. So then you have to check it off with the mark finally. So this right here is the same logic as what we saw up here. It's just maybe a little sleeker, a little cleaner. It depends to you what is more readable. But I'm going to copy and paste this from the solution notebook because it's a lot of checks. And if you want to be a little clever, you can make a little for loop for the rows and a little for loop for the columns, and then manually write in the diagonals. But let me copy and paste the solution and briefly go over it. Basically what we're doing here is we're doing that first way I mentioned. We're checking across the top, across the middle, across the bottom, down the middle, and then down the other columns, and then the 2 diagonals. All right, and what we're doing here is then we have an OR statement for each of these possible checks. And then after all of this, we're going to return the Boolean indicating true or false has somebody won. So we can have a win check here. Let's define this, win tic-tac-toe, the win check, and it looks like someone did win this tic-tac-toe. So let's actually display the board so we can see that. Display board, test board. So if we see this, definitely X has won in both fashions here, and it returns back true that this person has won. Great. So now step 5, we want to write a function that uses the random module to randomly decide which player goes first. And as we mentioned, you may want to look up random.ranInt. We talked a little bit about it in the useful operator lectures, but let's take a closer look now. One way we can use the random.ranInt is to just pass in 0 and 1 and treat that as what is essentially a coin flip. So we can say the following. We'll have our flip number be equal to random.randInt 0, 1. So this is randomly going to choose either 0 or 1. So we can think of that as heads or tails. And then we'll say if the flip is equal to 0, then we return, let's say, player 1 as them going first, else we return the string player 2 for going first. And there's lots and lots of different ways you could have done this, but this is kind of a simple way with the random.ranInt or random integer function. So let's run that. Okay, step number 6 was to write a function that returns a Boolean indicating whether a space on the board is freely available. So it's going to take in that board, which is a list, and then take in a position, and it wants to check if it's freely available. And for our case, freely available means that that position is currently an empty string. So to do that, what I'm going to say is get the board at that position, and then see if it equals a blank string. And since that's already itself going to be a Boolean, we're just going to return that. Then step 7 is to write a function that checks if the board is full and returns a Boolean value. True if full, false otherwise. So to do this, we're going to run a for loop that goes for I in range 1 through 10, because there's 9 spaces on the board starting from 1 and then up to but not including 10. We're going to say if, and then we can call our space check function that we just defined up here. So if space check, using that board at position I, so that's all the positions possible on the board, if space check returns true, then I'm going to, and this is kind of a double negative here, but we're going to return false. So what this means is if I have a space, that means my board is not full, so I will return false. Otherwise, if I go throughout this entire for loop and I don't return false, then I will return true because my board is full. So board is full if we return true. Okay, so that's the full board check function. Step 8 is to write a function that asks for a player's next position as a number 1 through 9, and then uses the function from step 6 to check if it's in a free position. If it is, we return the position for later use. So we'll do the following. We'll say position, and we'll have it be a placeholder at 0 because we know that at index 0, nothing's going on there. And we can say while position is not in the list of possible positions, so that can be 1, 2, 3, 4, 5, 6, 7, 8, 9. And we could have used range along with a list to make that happen. Or that space is not free, so we can say or not space check at board position. We'll ask the player for a position. We'll say position is equal to the integer of the input. Choose a position 1 through 9. And then finally, after all this, we're going to return that position. So all we're doing here is the following. We'll say position starts off at 0, and while the position, if the player for some reason is inputting the wrong number, or if they're inputting a letter, that's going to be this check to see if it's an actual number that's on the board, or it's going to check, hey, is that space still available? And then we're going to return the position once these have been satisfied. So we should only be calling player choice later on after we check if the board's been full. So the board being full is going to be a nice way to check if there's a tie, because if the board is full and nobody's won yet, then we know there's a tie. Okay, step 9 is to write a function that asks the player if they want to play again and returns a Boolean true if they do want to play again. So lots of different ways we can do this. One way is to just say input play again, question mark, enter yes or no, and we're going to say that's going to be their response. Let's just have that be their choice. And we'll say return choice equal to yes. So here we're assuming the person is actually putting in the correct values. If we get choice not equal to yes, basically they have to write yes perfectly, otherwise we'll assume they don't want to play again. All right, and that's our replay function. Now step 10 is the hardest part, where we actually have to code out all the logic. So this is going to be our largest block of code, so we'll finish this off in the next lecture. We'll see you there.